Archives, great and small, have changed dramatically over the past 10 years, and while the traditional manuscript archive, stacked with printed letters, monographs, maps, and photographs, continues to be the primary source of historical information for researchers, the digital age has shoved its way to the forefront of archival research through the sheer lack of information on preservation of born digital data, as well as the inherent nature of digital material being constantly in flux. Digital collection management is not limited to reformatting, although that data must also be saved, classified, and stored. The archival and records management industries are working to find a suitable method for saving born digital information or information never committed to paper. These factors have brought about several trends in the industries which combine traditional archival practice with data management tools. Changes to the hardware and software used in digital archives mirrors that of the computer industry itself. Drastic changes in information technology have occurred since the dawn of the computer age, and despite their youth, even the current generation of library and information science graduate students knows how quickly computer systems change. This is easiest to illustrate by the power and storage capacity of the Apple's iPhone series. The first generation iPhone was released in 2007 and had a maximum available storage capacity of 16 gigabytes. The most recent iPhone, the iPhone XR, released May 24, 2019, has a maximum storage capacity of 256 gigabytes. Quintillions of bytes of data are created every day. So what will we do with all that information? Obviously, most of it is not worth keeping. However, a lot of it is valuable for future research. After all, archive work is stewardship, which includes the preservation of the human record to ensure that future generations know what we know. Archiving the medium of digital has its benefits and challenges. Advantages include space saving and portable. Volumes of data can be stored on a single piece of media. Data can be located, accessed, and modified quickly. The difficulties, which are significant, include hardware and software obsolescence can render data irretrievable. Media can fail suddenly or unpredictably. Digital storage technology evolves quickly. Developing and implementing a strategy to systematically migrate digital data to the most appropriate storage media is vital. Failure to do so can render data difficult or impossible to retrieve because of hardware or software obsolescence. Just to collect the information will require monumental effort on the part of an archives, and options will have to be explored on whether or not to use in-house server farms or to rely on private contractors for digital space. I imagine some combination will take place, with some archives storing their digital collections on site and keeping copies of the same off-site. Which brings me to the concept of locks. Some software packages and tools provide for redundant storage. One of these is LOCKSS, LOCKSS. LOCKSS is an acronym for Lots of Copies Keep Stuff Safe. LOCKSS is a software system developed by Stanford University with funding from the Andrew Mellon Foundation and the Library of Congress. LOCKSS has also become something of a generic shorthand for decentralizing collections. The LOCKSS software is specifically designed to work with academic journals, but the idea could be used for other applications. It works by distributing published content to various libraries, then uses web crawlers to continually examine and update the information as needed. So if one source crashes, another has the same information. I also think the blockchain concept, which is a technology I'm not especially knowledgeable about, could be applied to LOCKSS-style archiving. Blockchain is a distributed ledger technology that theoretically could allow almost anyone with a computer and an internet connection to effect and verify transactions in a decentralized manner. With archival practice, this could be used to create a pay-for-play dark web system of archives, if that was desired. This could also be used to establish bibliographic control and document chain of custody. Now I'd like to talk about selection. One of the most crucial pieces of the digital archiving puzzle falls into the category of selection. In other words, what should be saved. In her 2012 article on digital selection for archives, Claire Ravenwood sums up the problem thusly. Properties of digital material present challenges to establish preservation selection drivers and practices, including the increasing volume of digital material, the complexity of some digital objects, changing forms of cultural object creation and ownership, and the need for early interventions to keep material usable over time. While the volume of digital information seems daunting, in the case of selection, traditional concepts of archival preservation can be applied. The Digital Preservation Coalition's interactive decision tree is a fun way to explore this idea. It is important to note here that there is not one established selection matrix that has been agreed upon as of yet. Different scholars and archivists have discussed varying criteria. Ravenwood et al. Lists 4 suggested criteria authorities: Gould and Ebden, Ugi and Morreals, the Disk Map Project, and the aforementioned decision tree developed by the DPC. Institutions should use these suggestions to model their individualized digital selection, collection, and preservation policies. Similarly to blockchain for storage, private sector data management firms are discussing methods of preservation selection for easily discoverable corporate data. In the private sector, where big data is the lifeblood of commerce, auto-categorization software is being perfected to self-categorize information for preservation. The easiest to understand example of this is your email spam folder. Your email automatically separates out information based on clues within the content dictated by the email program designers, often with your input. Big data firms are writing programs to automatically parcel out what to keep and what to delete. In conclusion, the most exciting and frustrating aspect of being a library and information science student hoping to work in an archivist's role one day is the stepping up to an industry in flux. In my research, it seems that no one really knows what's going to happen. While it is hard not to have ready-for-class answers on born digital preservation, it also opens doors to innovation. A lot of attention in the industry is being given to discussions on best practices in terms of hardware, software, and selection policies. This is an especially profound topic right now within the Society of American Architects. A search for Born Digital returned 99 articles written in the SAA's trade publication American Archivists since 2002. 30 of them were written in the last 3 years. Digital data management and archiving of born digital data will be the next step in the progression of professional historical archivism. While keeping up with advances in digital technology and changing selection matrix are a challenge, I believe it is one that the current students in the Library of Info Science are quite capable of.